Fluid cell pressing, or flex forming, is a low-cost sheet metal forming process designed for both prototyping and lower volume parts production. Avure Technologies is the world's leading supplier of these high-pressure presses, serving major manufacturers around the world. Recent advances in press and tooling design make this high-pressure forming technology more viable and affordable than ever for a growing number of metal fabricating companies. Flex forming is a basically simple concept. A sheet metal blank is placed over a single shape-defining tool half. The upper tool half is a flexible rubber diaphragm which is pressurized by pumping in oil. As pressure increases, the diaphragm forms the blank uniformly around and into the tool. When the set pressure is reached, the oil is decompressed and pumped out of the press. The diaphragm returns to its rest position, formed parts are removed, and new blanks are loaded for another cycle. Now let's take a closer look at the FlexForm press. The press frame is a horizontally positioned cylinder, reinforced with pre-stressed wire winding to safely contain the high hydrostatic pressure. The hydraulic system is typically housed above the press to conserve floor space. Tools and blanks are loaded into large forming trays on tables that shuttle in and out of the press. Parts are placed in the tray with no need for fine alignment or fixing in place. Fluid cell forming has proven to have a number of economic and processing advantages, particularly when compared to rubber pad pressing and mechanical or hydraulic stamping. Unlike the 2- or 3-piece tool sets used in stamping presses, flex forming requires only a single shape-defining punch or die, cutting tool costs by 50 to 90%. Tool matching and alignment procedures are eliminated, and with the uniformly applied pressure, stresses in the tool are almost purely compressional, permitting the use of inexpensive, lower strength, easy-to-machine materials such as hardwood and plastic. Very high pressures up to 1400 bar or 20,000 psi form parts to precise tolerances with little or no manual correction. Intricate shapes, including undercuts and holes, can be produced, often in one operation. Tools can incorporate cutting edges to eliminate downstream trimming. Multiple parts can be processed in a single cycle. Virtually any sheet metal from 1/10 of a millimeter to more than 16 millimeters, 0.004 to 0.63 inches, can be formed. Different gauges can be formed on the same tool. Surface finishes are free from scratches or gall marks. Lead times are dramatically shortened for both prototypes and production parts. Complex parts can be designed and produced that would be prohibitively expensive with conventional presses. Large, intricate parts can be formed, allowing designers to combine smaller components into single seamless units, saving downstream assembly time and the extra weight of welds and fasteners. Cost efficiency is paramount in the globally competitive aerospace and automotive industries, and Avure has responded with advancements in product design and forming technology. Today, a variety of press sizes and capabilities are available to conform to the specific operational and volume requirements of both OEMs and their contract suppliers. Avure offers FlexForm presses in 3 basic styles. QFC presses have the largest forming capacity, with dual rectangular trays up to 8 square meters that can form parts well over 4 meters in length. Standard maximum pressures are 1,000 and 1,400 bar. Recently, an intermediate-sized QFC press has been introduced with a 1 by 2 meter tray and 800 bar maximum pressure. QFL presses are compact units with 1 meter diameter circular trays, designed for faster forming of smaller parts. Cycles average about 1 minute, with maximum pressure of 800 bar. Any part configuration that can be manufactured on conventional rigid tools can be produced by Flexform presses. These include single and compound curves, contoured parts with stretch or shrink flanges, shallow recesses, and deep-drawn parts. Designs can incorporate forming features such as internal and external beads, lightning and access holes with or without flanges, and joggles to provide space for adjoining parts. The sheet metals most commonly formed on the fluid cell press are mild steel, high-strength steel and aluminum alloys, stainless steel, and titanium. Other materials can include nickel-based alloys such as Hastelloy, Inconel, and Mnemonic 75. Single-piece tooling is the primary reason for the growing adoption of flex forming among sheet metal parts fabricators. There are 4 basic types of fluid cell tools. The punch or mail die is the simplest, least expensive, and most widely used type of fluid cell tool, having the same shape as the internal surface of the pressing. The punch can be augmented with a blank holder that supports the entire unstressed area of the blank. This reduces the risk of drawing too much of the sheet metal into the forming area, which may result in wrinkling. The die, or cavity die or female die, consists of a central cavity surrounded by a flat or curved section upon which the blank rests, thus eliminating the need for a separate blank holder. The surface of the die produces the external surface of the pressed part. An expansion die is used when the blank is to be pressed radially outwards into undercuts in the cavity. The die is made in 2 or more pieces and is pulled apart after the pressing cycle to allow removal of the parts. Because cycle times range from 1 to 3 minutes, fluid cell pressing has not been considered to be a mass production technique. That being said, many companies use Flexform presses to supply the great majority of their sheet metal parts, taking advantage of unique processing features. Many parts can be formed in a single cycle. The dual tray system results in very short setup times, an important consideration with batch sizes that require frequent tool changes. Current tool designs produce a high percentage of finished, trimmed parts directly off the press, with no downstream rework. Quick cycle presses like the QFL can produce up to 120 finished parts per hour. Automated pallet systems preloaded with tools and blanks are available to cut handling time between cycles. Today, nearly 140 Flexform presses are in operation worldwide. Some have been performing successfully for more than 30 years, and a few have achieved or are approaching 1 million cycles. Discover what leading manufacturers already know about the advantages of high-pressure sheet metal forming from Avure Technologies. Log on to www.avure.com for complete details.